Hi, welcome back to Moose and Chemistry. This is Colligative Properties lesson number 2. Remember that we're going to be using the freezing point of pressure, which is delta TF equals I KFM, and the boiling point elevation was delta TB I KBM. We're also going to be using the Van Hoff factor today, and we're going to be using molality, which is moles of solute over mass of solvent in kilograms. All right, let's go ahead and get started. The first problem actually has two parts to it. If I have 45 grams of sodium chloride and 500 grams of water, what will be the melting and boiling points of the solution? Okay, well, first of all, we got to turn 45 grams of sodium chloride into moles of sodium chloride before we can do this. So we go 45 grams of NaCl times 1 mole of NaCl divided by 58.44 grams of NaCl. Now, where did that 58.44 grams of NaCl come from? Well, that came from our molar mass. Remember that we go sodium is 1 times 22.99, Cl is 1 times 35.45, and that gives me a total of 58.44 grams per mole. All right, now, so our grams cancel out, and that gives me approximately in our moles 0.77 moles of NaCl. All right, now we have our moles. So the next thing we got to think about is using our constants here. So the freezing point of water, the constants for the Kf is going to be negative 1.86 degrees C over M, and that's a constant. And of course, the constant for boiling is going to be, of course, 0.51 degree C over M. So these are constants. When we talk about the Kf and the Bf, that's for water. You have to remember that I didn't put down any numbers with this because each solution is different. Each solution has its own freezing point and its own boiling point. When we're talking about water, its freezing point is negative 1.86, and the boiling point of water is 0.51. All right, so let's go ahead and let's figure out our delta TF and our delta TB. We have our moles of sodium chloride, so we need to go ahead and we need to also remember we have to change 500 grams of water into kilograms of water, right? So you're going to go 500 right here, and you're going to go 1, 2, 3, and that's going to give me 0.5 kilograms of water. Now we can do our molality. So we take M equals 0.77, right? And we're using our molality formula, which is that one right there, divided by our 0.5 for our kilograms, and our M value is now going to give us approximately, let's see, 1.544 molar. Now we are ready to do the problems, finally. So we go delta TF equals IKFM. All right, so let's do that one first. Ooh, look, we have one more thing to think about this. This is sodium chloride, right? That's NaCl. So NaCl, let me show you what happens here. NaCl is going to break down to Na ions and chlorine ions, right? So the Van Hoff factor is going to be 1 plus 1 equals 2. So our I value is going to be 2. Now we have all our plates. So we got delta TF equals 2 times the freezing point, which is of water, which is negative 1.86 degree C over M, times our M value, which was 1.54. Things can really add up on us really quickly. So our delta TF value is going to be negative 5.72 degrees C. So now it's asking us to find the freezing point. So we go delta TF equals 0 plus negative 5.72 degrees C. So our new freezing point, our new delta TF, is actually going to be negative 5.72 C. That's our freezing point depression. So it actually turned out to be the same number. But what about the boiling point? So what's the new boiling point? Well, we take delta TB equals IKBM. All right, now remember same Van Hoff factor, so we can say delta TB equals 2 times 0.51 degree C over M times our molality, which is going to be 1.54 M. All right, now our new delta TB is going to be 1.54 degrees C. So if we want to know what the elevation is, you go delta TB takes the boiling point of water, which is 100 degrees C, plus 1.54 degrees C. This, our new delta boiling point, is going to be 101.54 degrees C. That was a lot of work to do that problem, but that's it. All right, now let's look at the next problem. The next problem is, what is the boiling point elevation when 11.4 grams of ammonia, NH3, is dissolved in 200 grams of water? Well, the first thing I want to do is take the 200 grams of water and change that into, of course, kilograms. So I take 200 grams of H2O, and I want to change this into kilograms of H2O. So I take 200, and I'm going to go 1, 2, 3. That gives me 0.2 kilograms. But now I've got to change these 11.4 grams of ammonia into moles of ammonia to get our molality, which is what we're looking for, right? So now let's see here. We've got to figure out the molar mass of NH3. So we have N is 1, H is 3. This is 14.01. I'm getting that from the periodic table. And it's 1.1. So this is going to give me approximately 17.04 grams per mole of NH3. All right, now we're prepared to find our molality first. So we take, you have to do one more thing before we do that. So we're going to go ahead and set this up and put the 0.2 down here. But we also need to know what is the number of moles. So we go 11.4 grams times 1 mole of NH3 over our molar mass, which is 17.04, right? So grams cancel out, and that gives me approximately 0.67 moles of NH3. Now I can put that 0.67 there. I know, a lot of writing. All right, so now when we divide those two together, we get our molality to be 3.34 little m. Now we are prepared to do our problem. All right, so we go delta TB equals IKBN. But you know what? Luckily for us, our Van Hoff factor is just going to be 1 because NH3 is not an ionic compound. So there are no ions. So we take the Kb for the boiling point of ammonia, which for the water part of it, is going to be 0.51 degrees C over M times our 3.34. So we're going to 3.34 molar there. Our M's cancel out. And our delta TB is going to equal 1.70 degrees C. And that's it for this lesson, guys. You be snarly, and we'll see you back here at Moosing Chemistry.